Okay, last lesson in 412, we worked on decimal addition algorithms. Today we're going to work with decimal subtraction algorithms. And so our objectives are to be able to review whole number subtraction algorithms and use them to subtract decimals, to understand the place value system, and perform operations with multi-digit whole numbers and with decimals to the hundredths. So to start off with, let's do some of our mental math here. It says write on your slate or paper a decimal with the same number of digits that is larger and one with the same number of digits that is smaller. Okay, so I have to use the same number of digits, so I think of the one that's smaller. I got to obviously stay here in the tenths, so I'm going to say 3/10. And one that's larger with the same number of digits, I could say 4. I could say 5/10. I could say 6/10, 7/10, 8/10, 9/10, or any whole number, right? And so let's look at one more here, and then you'll be able to do the rest. So let's see, a number that's less, same amount of digits. I could do 74 hundredths. And if I wanted to do one larger, like I said, I could do 76 hundredths. I use the same amount of digits, but they have the larger and the smaller. So same thing you want to do here. So think about what does 53 hundredths come between? What does 9 hundredths come between? And the same thing on this one. Think about 219 thousandths and 3 thousandths. What are two numbers that comes between? So just to review, we talked about this in the last lesson. Algorithm is a set of step-by-step instructions for doing something, such as carrying out a computation or solving a problem. Counting up subtraction, a subtraction strategy in which you can count from smaller to larger number to find the difference. For example, to solve 16, subtract 9, you could count from 9 to 16. You have the trade first subtraction method, in which all trades are done before any subtraction is carried out. You could do US traditional subtraction, which is what most of you do. A subtraction method that involves subtracting digits by place value column, starting from the right, making 10-to-1 trades as needed. So let's look at this problem here. I'm going to use cubes, as we should always use on our story problems. I'll use a different color here. So Carolyn had 9 4800ths meters of cloth. She used 7 291 thousandths meters to make a dress. How many meters of cloth does she have left? So then I see the keywords have left, and I also see she used. So that tells me I'm going to be subtracting. So I'm going to take 9 4800ths, and remember, you always want to line up your decimals, not the numbers. So once you finish lining up, if you find there's a blank spot when you're subtracting, you just add a 0. Okay, so just add a 0 in that blank spot. Bring your decimal straight down. And then I can borrow, right? So that becomes 7, 10. 10 minus 1 is 9. Now I can't take 9 from 7, so I have to borrow again. And it's a group of 10, so that becomes 17. And that gives me 8. And then I can't take 1, then I can take 3 minus 2, which is 1, and 9 minus 7. Okay, so I should get to 189 thousandths. The one thing I didn't do beforehand that we should have done is an estimate. So I'm going to go back and do that because it did ask us to do that, and I forgot. So I'm going to just say that's pretty close to 9 because $9.48 is closer to 9 than it is to 10. And I'm thinking that is about $7.29. So I'm going to say 7. So 9 take away 7 is 2. So my estimate's about 2, and my answer is 189 thousandths meters, which is pretty close. It shows me that my answer is reasonable. Doesn't guarantee I subtracted correctly, but it is reasonable. Okay, so here's some number models you could have done. You could have rounded each decimal you could have rounded it to 9.5 and 7 3/10. So got 2 2/10 for your estimate, or you could have done what I did and just take it to the nearest whole number and then find the difference. Estimates are useful for checking whether your exact answers make sense. In an earlier lesson, you used grids to subtract decimals. Do you think using grids to solve this problem would be a good strategy? Why or why not? I think it could be, but you're getting into pretty big numbers on the grid, right? 7 whole grids and then 291 thousandths. So you'd have to have 7 whole thousandths grids to color, and I think that would be a lot of work, right? So I don't think that's the best strategy. So today you'll explore how whole number subtraction algorithms can be applied to decimals and use algorithms to solve the decimal subtraction problems, so you don't have to color a grid every time. So we're going to skip this. Here are some common problems when people are working with the trade first there. Okay, so you can see they did 9, take away 7, okay, and then they borrow from the 3, and they get 2, and then they get 17, but they forgot to take away from the 17. I'm not sure what they did there. Okay, but then you look at U.S. traditional. Big thing is just borrowing. Make sure that you're borrowing and that you are accounting for all the numbers as you trade and you borrow. Okay, so how can we rewrite 9 4800 so it has the same number of digits after the decimal point as 7 and 291 thousandths? So just like I showed you before, you could just add in a 0 to make it into the thousandths place. And that doesn't change the value of the number. It just makes the pieces smaller, but that is okay. So when using counting up subtraction, there may be a struggle deciding what to add first. It can be helpful to use counting up steps to the next highest 10th, 100th, or 10th. So you can see here the pink shading shows the decimal part of the smaller numbers, 2 and 91 thousandths. The green shading shows what to add to get the next 100th and 10th. The blue shading shows what to add to get to the next whole number. So what is the answer to the math message problem? Does the answer make sense according to our estimates? So based on what we looked at before, when I got my answer, it was reasonable with my answer. All three algorithms, trade first subtraction, counting up subtraction, U.S. traditional subtraction, reliable methods for subtracting decimals. Okay, most of us are used to doing traditional though, and so you probably want to stick with what you're most comfortable with, whichever strategy that is. Which algorithm might help you get accurate or correct answers? That's something to think about as you choose a strategy. Which one might be the most efficient or the quickest one for me to use? So those are the two things you needed to think about as you choose a strategy. People have different answers to these questions, and you should choose the algorithm that works best for you. So turn in your math journal, page 148, please. And go ahead and pause the video and solve the problems on this page. But before you do that, there is one thing I want to point out. Again, you see here I could add in a 0 because it goes all the way to the thousandths. Remember to line up your decimals, not your numbers. You can always add in zeros if the numbers don't quite match up. Most of these they will. Okay, so pause the video at this point. Make sure you complete each problem before you come back on and check. All right, so you should have completed each problem. So we'll just go through and look. You can see their estimate is 2. Yours may be a little different, but it shows that it's reasonable. Their estimate is 4. They chose whole numbers here. And you can see it's close to their answer. It's reasonable, makes sense. Here they chose to keep 2.5, to go to 2.5 and keep 7 as a whole number. Here they chose to work with whole numbers for estimate. It was very close, so make their answer is reasonable. Here we can see they did 62.5 from a whole number of 20. And it showed their answer as being reasonable. And then our last one, they did 2 whole numbers and found their answer was reasonable. Again, your estimate being close to your actual answer doesn't always mean that it is correct. It just means that it's reasonable. So on here it says choose one problem. Think about the algorithm you use. Answer the questions below. How did your choice of algorithm help you get an accurate answer? What was your choice of algorithm the most efficient choice? So did it help you get the answer the quickest? Why or why not? So make sure you answer that. That's kind of on your own thinking there. Okay, and then okay, and then so that is it. You want to make sure that you work on your math boxes.